This is chapter 5, problem number 17. All right, let's look at this guy. He's holding something in his back. A man attempts to support the load of board having a weight W and the center of gravity at G, at point G. If he is standing on a smooth floor, determine the smallest angle theta at which he can hold them up in the position shown. Neglect his weight. All right. Well, what is the question asked about? Okay, so with this one, if see this point is over here, okay, so how do I know that whether this thing will flip over? Okay, so let me give you an example. If you have an object, okay, if you have an object like this, will this one flip over? Let's say the friction is very high and it will not slide down in this direction. Okay, so will this object flip over? So you compare that object with this object over here. Okay, if you have an object like this, will this one flip over? Well, based on our common sense, yes, you will think, yes, this one is going to flip over, but the short one will not. And why? Okay, so graphically, let me show you the easiest way to interpret it. So this is the center of mass. So you draw a free body diagram. This will be the center of mass. You draw the free body diagram. If this line is out of its support over here, it will flip over. Look at this. The support, the base is over here. And now this line is outside of this support. So this one is going to flip over. This one will not. If you have, so what is the angle? Okay, so if you have, for example, like this one is going to barely survive because it's right within the distance of the base over here. So if I change the angle theta over here, that means I make it flatter. Okay, so I'm going to draw it like this. Okay, with the same block. Okay, so if you change the angle, okay, so now this is the minimum angle or the maximum theta that you can have. If you look at another case, okay, where it's almost flat, in that case, no, this one will not fall down. Okay, the extreme case will be if theta is equal to 0, then you have it sit like this, it will not fall down. All right, this may be new to most of us. Okay, so when the center of gravity, if you draw it a line like this, if it's outside of its support, then it will flip. So let's look at this problem. Okay, how do I know whether this will flip or not? Okay, so let's look at this one. So I have mentioned before, if center of gravity is outside of this level here, then it's going to flip. So the base, I have 3 feet over here. Okay, so this one, I have 4. If you do it like this, okay, so this one is 4. So if you draw the free body diagram, you're going to draw the point over here, okay, and you want to see if it exceed that one. So this is a 3, this is a 4, and what would this angle theta? All right, so this one I have theta, that means cosine of theta, that is equal to 3 divided by 4. All right, so I use my calculator and it shows that theta is equal to I don't know if we can see it. All right, forget it. I can see it. All right, so it will be equal to, so 3 divided by 4. Can you read it? No? Okay. And take a cosine, second answer, 41.1. Okay, 41.1. That means if this theta is less than 41.1, then this thing is going to flip over because the center of gravity is outside of the support. If you make it straight up high, okay, or for example, if this person is holding the board like this, then it will not flip. The lucky number for this problem is 9.